Okay, so there's two operations that the book would call basic vector operations, right? These are the basic vector operations. Operations. Again, when we did matrices, since vectors are matrices, then they were really kind of the same thing. We knew how to add up two matrices, just add up all the entries. We knew how to multiply a matrix by a constant, that just multiply everything by the constant. That's pretty much what these are too, right? The definition of vector addition, if I add two vectors, u and v, it just means add up the first components and add up the second components. Right? If you write them in the component form, u1, u2, v1, v2, then u plus v is angle bracket, u1 plus v1, comma, u2 plus v2. Right? Scalar multiplication, and we used that word too when we did matrices. Scalar multiplication means multiplying by a constant, not a matrix, not a vector, just one number. And here it's represented by k as the constant. K times the vector u is like k times u1 comma u2, and that's k times u1 and k times u2. Just it's like distributed, right? Just multiply everything by the constant. Now notice the way that they've drawn their vectors here, right? They put both of these vectors different positions, right? But remember, position, a vector doesn't really have a position. If you could move it around anywhere, you could make both of them start at the origin in standard position. But if you wanted to see a graphical representation of adding two vectors, what it means is putting those vectors end to end. So u plus v would mean here you go from the initial point to the terminal point. Okay, well take the vector v and move it up here. So now its initial point is the terminal point of u, right? And then you get this picture here, right? There's u and there's v. And this here, that's the sum. That goes by the name, and this comes up, right? Resultant. When you add two vectors, the sum is called the resultant. Now notice the other part of this picture is, if you would have, instead of tacking v onto the end of u, if you would have tacked u onto the end of v, that would have been this right here. Okay, does that change the resultant vector? No, it's the same thing right there. So it doesn't matter the order that we add the vectors. You're going to get the same result.